วัสดีค่ะดิฉันนางสาววลัยลักษณ์นุ่นช่วยรหัสนักศึกษา6200242สาขาวิศวกรรมเครื่องกลแห่งวิศวกรรมพลังงานวันนี้จะมาสอนทำ 2D Heat Transfer Analysis in Acid Workbench นะคะอันนี้ก็คือรายละเอียดที่เราต้องทำนะคะต่อไปเราก็เปิด Workbench นะคะแล้ว Steady State Thermal อย่าลืมเซฟลงในอันแล้วก็อันนี้แล้วก็อันนี้02ก็ edit เติมเนี่ยลากไอโซโทปิกอันนี้เปลี่ยนเป็น BTU ถั่วเอาอันนี้เป็นแม่แล้วก็โอเคก็คลิกปิดเชื่อไม่ได้อันนี้เปลี่ยนเป็นดูดิ
for a new conductivity design. Similarly, I'm going to add some D. So I have a different D, conductivity of 0.084. edit เพิ่มอีกอันมีแมทซีนทาเมทซีเมทาน0จุดโอเคก็มี1 2 and I'm going to uncheck that one, so disable that default structure speed. So I'm going to save. So once it's saved, so now I can close that. Next step is in the geometry. You just select analysis type as 2D.
อันนี้เป็น
For that one,
2D
click on geometry. Click on geometry and from view, check on the properties and geometry, and then you have here 2D. And then in the geometry, the next step is to start new design model spec. So right click on that and new design model spec. So that is new.
เปลี่ยนยูนิตก่อนเดี๋ยวอันนี้ก็ดิเมนชันแล้วก็บอกขนาดเป็น12นิ้ว14นิ้ว12นิ้วแล้วก็14นิ้วหลังจากนั้นก็ไปที่ modify drag บนวะเลยวะโอเค constraint symmetry
Y-axis. So
y-axis
like that way, and then these two, so they are symmetrical. Now uncheck it and click here. And then make this symmetrical, and then these one. So now that is modeled. So here you can see that this that's one. Okay, so once is that sketch one. So sketch dimension, then concept. So the concept, just click on that, and then in concept, success found sketch. This okay, and then generate. And you can see that here one part is being generated. So I named it as concrete. Okay, and then generate. And you can see that here one part is being generated. So I named it as concrete. So that inner side is being named as concrete. The next one, you need to follow the same steps, and only in operation you need to add frozen. Like when the concept, after concept you need to add operation, add frozen. So the breaks inside is a square, 14 by 14, and outside is 26 by 26 square. So for that purpose, here in the sketch, sketch 2, and I am going to draw a sketch on top of it. So it's very simple, a rectangle. Right on there. Okay, this turned blue is that is right on the top, and then and the other one it is required is 26. Okay, so for that one, another rectangle, I'm just looking for a random rectangle. Okay.
เท่าไหร่อ่ะ นับก่อน โอเค
And in general, I am going for that is 29 and that is 25. So both required as 26. So and then with the constraints, you can add a symmetry here. For both of these become symmetrical, and then symmetry about x-axis that will be symmetrical. So now in the modeling, I'll go sketch, and then sketch, and then dimension, and then concept.
concept.
Here in the concept,
อ๋อ ทำเดิม surface from sketch.
this from sketches, and important here. important.
Ah, ทำไมขึ้นไม่เหมือนกัน อ้าว
So when you have two, so to give a connection between these two, you need to add frozen, okay, and then generate. So now you can see that there are two surfaces, one is the inner surface, one the outer surface. So that one I'm going to rename that as brakes. So for complete, so is that one for complete. So I left that operation
surface 1 add material
as add material. But for surface to sketch 2, I need to add frozen. So now that design is complete. I can save that and then material. But for surface to sketch 2, I need to add frozen. So now that design is complete. I can save that and then, so once it's saved, I can simply close that design model. The next is battery. You need to input the model and then, so for that model, you click on model and it will open a new window. That is now new window for model, and the first we need to
material
assign
assignment
material, but before that we need to change the units. So in the home, while clicking on that model, the home, so you have these units. So it is taking that units as inch, then pound, Fahrenheit, and then second. Or other one is foot, pound, Fahrenheit. So let's say I'm going for inches because
degree
actual units they were in inches, or otherwise you can here to change the units. So inches, pound, units are there.
okay.
So the first is in the geometry. I have two there. Complete. So there is a question mark on, and then
surface assignment
that highlighted assignment. So I am going to select complete. So there is a question mark on, and then that highlighted assignment. So I am going
out
for that, and then is the brakes.
okay.
Next step is to create path using the successive geometry, and by the path required because temperature distribution about that one or temperature distribution about that one is required. And first, see that where is the origin
coordinate system
for this system. So I'll go to the model and then
model
the model, this is a construction geometry. I'm going to create a path. So that is the path, and it is
in the part
asking about that what are the coordinates. So I want to draw a path from here going upward. So from inner hot surface to outer cold surface. And for that one, we need to put coordinates upward. So from inner hot surface to outer cold surface. And for that one, we need to put coordinates. So now, for the start, coordinates 0 and 6 and 0 and 13 are the values. Now that is the path, so I'm going to rename that.
rename ว่า heart rate
That path. Next step is check connections, and for that contact region, and the type bonded. So these two surfaces, I'm assuming that they are bonded, and for that one, go to connection, and then
connection contact region
and then contact regions. So here you can see that it is two regions, although here they are shown as two. So inner, and that is the concrete and then brick, and then type here is bonded. So you can use any other than bonded wire. Next step in the model is mesh, and for that one, by defining any element size, we need to create mesh. So here is the mesh, and for the mesh, display type using geometry, physical preference is mechanical, okay, and then element order, program control, and default value for the inch. So let's say I am going to use that half inch, 0.5, okay, and then generate mesh. So with the half inch that is being generated, or otherwise I can go for a quarter inch, and then update that. So with the element size 0.25 inch,
0.5 พอนะ 0.25 เดี๋ยวรันไม่ได้
that is the mesh, and I'm going to use that.
ดู
The next step is setup in the steady state thermal, need to apply boundary conditions.
steady
And for that
state
one,
thermal
the environment tab, go to convection, and then scope geometry, and then select all those edges, and then the definition, the coefficient, and temperature. So for that purpose, use the steady state thermal, go to steady state thermal, and then in the environment, use the convection, and I'm going to rename that convection and inside. Okay, and then for that inside, I'm going to select the edges. temperature is 140. So for inside, the heat transfer coefficient is 0.037. That one here, 0.038 minus. That is, here you can see inside maximum light, and now for outside. So battery first state is black. Control. Four edges, here select, apply. So here 4 edges. The temperature outside is 10. And transfer coefficient for outside is 3. Yes.
E
So that one.
one.
I'm going to rename that as
Outside,
so the convection
inside.
inside and convection outside both are applied. 1.0278 in 10 to the minus 5. The other one is 3.6 10 to the power minus 6. Next step in the solution, we need to create temperature for cold and then temperature for along that path. So for that purpose, in the solution, there is an option insert thermal temperature, and that is the temperature for all bodies. And otherwise, go to the solution. The thermal temperature and that temperature from that path, and we will rename that the temperature along that path.
PATH.
And for that one, then here for temperature path and reflection is
Hot. PATH.
now that all the solution is required is done. So next step is solve. So here click in the solution and then solve. It will take some time to get results. So as green tick appeared on all that particular solution required, so results are ready. So the next step is to plot temperature distribution about that path, which is through concrete and then through bricks. So for that one, click on that is the temperature profile and then that is the path.
Temperature
And
path.
here
อันนี้
is
total
along
heat
that
flux
path,
แล้วก็
the
total heat
temperature
flux path.
distribution. And then by default it is 47 for
Graph.
that path. So like that, this number of sampling is 47. So I have here like the total length of that is 7 and element size I set as 0.25. So there are 28 steps are required. So number of sampling time going to apply there, and then I solve it again. So here you can see the temperature along that path is so here you can see the temperature. Right.
อ๋อมันซูมได้ อ๋อแม็กกับมิน
So here you can see the temperature
อันนี้
124,
เล้งอันนี้ value
and then temperature at the interface is
โอ้โห
11.67 and goes down. So that is the temperature. And similarly, that is the total heat flux, and that is the total heat flux distribution. Like that is 1.567.
สำหรับคลิปนี้ก็ขอจบแต่เพียงเท่านี้นะคะ ขอบคุณค่ะ